There are more stars in the universe than grains of sand on Earth. The sheer number of stars in the universe is mind-boggling. The observable universe contains at least 100 billion galaxies, and each of these galaxies can have hundreds of billions of stars. That means there are an estimated 1 septillion stars, one followed by 24 zeros. To put that into perspective, it is believed that there are more stars in the universe than grains of sand on all of Earth's beaches combined. And that's just what we can observe. The universe might be much larger than what current telescopes can detect. Each star could potentially host planets, many of which could be Earth-like, leading to infinite possibilities for life beyond our solar system. The Sun makes up 99.86% of the solar system's mass. The Sun is an incredibly massive star containing 99.86% of all the mass in the solar system. With such a dominant gravitational pull, it governs the orbits of the planets, asteroids, comets, and even distant objects in the Kuiper belt. The Sun's mass consists mainly of hydrogen and helium, the fuels for the nuclear fusion that powers it. Every second, the Sun converts millions of tons of hydrogen into helium, producing the light and heat that makes life on Earth possible. Without the Sun's gravitational force, the planets would drift off into space. Its size and mass make it a critical element for maintaining the balance of the solar system. Saturn's rings are mostly ice. Saturn is perhaps best known for its stunning and complex ring system, which is primarily composed of chunks of ice. These icy particles range from tiny dust grains to massive boulders the size of mountains. The rings, stretching up to 175,000 miles, 282,000 kilometers wide, are believed to be the remnants of comets, asteroids, or shattered moons that were torn apart by Saturn's strong gravity before they could collide with the planet. Saturn's rings are divided into multiple groups, with each group containing thousands of smaller ringlets. Despite their enormous size, the rings are extremely thin, sometimes measuring less than 30 feet, 10 meters in height. Their icy composition reflects sunlight, giving them a brilliant glow when observed from space. The hottest planet isn't the closest to the Sun. While you might assume that Mercury, being the closest planet to the Sun, would also be the hottest, it's actually Venus that takes the title of the solar system's hottest planet. Venus has a thick atmosphere composed mainly of carbon dioxide, which creates a runaway greenhouse effect. The atmosphere traps heat so effectively that surface temperatures on Venus can reach a staggering 900 degrees Fahrenheit, 475 degrees Celsius, hot enough to melt lead. In contrast, Mercury has virtually no atmosphere to trap heat, so while it gets very hot during the day, reaching temperatures of about 800 degrees Fahrenheit, 427 degrees Celsius, it also cools down drastically at night to negative 330 degrees Fahrenheit, negative 200 degrees Celsius. Venus, however, remains consistently hot day and night. Black holes can spaghettify objects. Black holes are regions of space where gravity is so strong that nothing, not even light, can escape. If you were to get too close to a black hole, you would experience a process called spaghettification. As you approach the event horizon, the boundary of the black hole, the gravitational pull on your body would become dramatically stronger on one end compared to the other. This difference in gravity would stretch your body into a long, thin shape, much like a strand of spaghetti. This is caused by tidal forces that are so extreme near a black hole that they can tear apart entire stars. Once something crosses the event horizon, it's pulled inexorably toward the singularity, the black hole's infinitely dense core, where the laws of physics as we understand them break down. There's a rogue planet floating through space. Rogue planets are free-floating planets that do not orbit a star. Unlike Earth or other planets in our solar system, these planets drift through space, untethered by the gravitational pull of a sun. Scientists believe these rogue planets form in the same way as planets in solar systems, but they get ejected from their systems due to gravitational interactions with other planets or stars. It's thought that there could be more rogue planets than stars in the Milky Way galaxy. Since they don't have a star to provide heat, rogue planets would be incredibly cold and dark, but some may have internal heat from their formation or tectonic activity, which could allow for some forms of life in their subsurface environments. Jupiter has 92 moons. Jupiter, the largest planet in our solar system, has a staggering 92 known moons, and new ones are discovered frequently as technology improves. These moons vary greatly in size and characteristics. Ganymede, Jupiter's largest moon, is not only bigger than Mercury, but also the largest moon in the solar system. It even has its own magnetic field. Other notable moons include Europa, which has a subsurface ocean and is a candidate for potentially harboring life, and Io, which is the most volcanically active body in the solar system. These moons play crucial roles in shaping Jupiter's magnetic field and ring system, and they are of immense interest to scientists who study planetary formation and the potential for life in icy moons. There could be multiple universes. The concept of the multiverse suggests that our universe might be just one of an infinite number of universes. This idea comes from theories in quantum mechanics, string theory, and cosmology, where certain models predict that there are other universes with different laws of physics, constants, and even dimensions. Some of these universes could be similar to our own, while others could be vastly different, with alternate versions of reality. While there is no direct evidence for the multiverse yet, it remains an exciting area of theoretical physics, and future advances in technology and understanding may one day reveal more about the nature of existence beyond our universe. A day on Mars is only slightly longer than a day on Earth. Mars, often called the Red Planet, has a day length remarkably similar to Earth's. A Martian day, known as a sol, is about 24 hours and 39 minutes long. This slight difference has important implications for future Mars missions, including potential human colonization. The similarity in day length means that astronauts and future settlers would experience a relatively familiar cycle of daylight and nighttime, making adaptation easier compared to other planets or moons where days are much longer or shorter. This consistency could also make it easier to schedule daily tasks and activities, especially for solar-powered technology, which would rely on a predictable pattern of sunlight. While there are still significant challenges to overcome, such as Mars's thin atmosphere and extreme cold, the familiar length of its days offers a glimmer of hope for more practical human habitation. The largest asteroid in the solar system is almost a dwarf planet. Ceres is an extraordinary object in the solar system. Discovered in 1801, Ceres is the largest object in the asteroid belt, the region between Mars and Jupiter, where most asteroids are found. With a diameter of about 590 miles, 940 kilometers, it is so large that it qualifies as both an asteroid and a dwarf planet. Ceres is round due to its gravity, which gives it a similar status to other dwarf planets like Pluto. Its surface is rich in ice, and scientists have even detected evidence of water vapor, suggesting that there could be liquid water beneath its icy crust. This makes Ceres an object of great interest in the study of the early solar system and the possibility of life elsewhere. In 2015, NASA's Dawn spacecraft visited Ceres, revealing mysterious bright spots on its surface, which are believed to be deposits of salts left behind by evaporating water. Ceres continues to intrigue astronomers as a key to understanding the composition and evolution of the solar system. The Moon is moving away from Earth. The Earth's relationship with its Moon is constantly changing. Every year, the Moon moves about 1.5 inches, 3.8 centimeters, farther away from Earth. This gradual movement is caused by tidal interactions between Earth and the Moon. As the Moon's gravity pulls on Earth's oceans, it creates tides. Over time, the gravitational interaction slows Earth's rotation and transfers angular momentum to the Moon, pushing it slightly farther away. While 1.5 inches per year might seem insignificant, over millions of years, this gradual drift has real effects. For example, billions of years ago, the Moon was much closer to Earth, and its gravitational influence was much stronger, causing more extreme tides. In the distant future, the Moon's increasing distance will affect the length of days on Earth, making them longer. Eventually, Earth and the Moon could become tidally locked, meaning that the same side of Earth will always face the Moon, much like how one side of the Moon always faces Earth.